Okay, start the recording. A couple of reminders. I believe the ratios and proportions assignment is due today, and we'll take it up in class tomorrow. So try to hand it in today, but definitely hand it in by the time we take it up. Because last time a lot of people forgot, even by Thursday. So yeah, it has to be in by the time we take up the solutions. So everyone, please make sure to do that. What else? So I guess that's it for now. I don't think we'll have a test on chapter 3, or we might have it included with chapter 4. We'll see. But chapter 3 isn't very long, so it's like I usually don't bother doing a test on it. Okay, does anyone have any questions before we start? Okay, everyone seems good. Okay, let's share screen. So we are, oh, actually, no, I don't need that right now. Let's go to the PowerPoint. Okay, so chapter 4, measurement, and we are starting with the metric system, which is a chapter that I actually like. I like the metric system. I think it's a really clever system, like compared to, for example, the imperial system, which requires like a million different tables that you have to look stuff up on. But the metric system is definitely the simplest and most clever system that they've come up with. But because it's so elegant, a lot of people have a hard time understanding it because it's almost like so compact and simplified that some people kind of overlook certain things. So it's a very good, elegant, clever system, but you got to get the hang of it. So this is the metric system that we're doing right now. Okay, so the metric system is an international system. It's used in Canada and in virtually every other country except for America, and I believe 1 or 2 other countries. But otherwise, the metric system is used by pretty much every country. So it's also known as the SI unit system, which is French for Le Système International de Units. I definitely pronounced that wrong. So it's a decimal system of units for mass, length, time, and other physical quantities that is used worldwide, also known as the metric system. Okay, so the SI consists of one primary unit for each quantity to be measured, and a set of prefixes used with the primary units to create larger or smaller units. So what the heck does that mean? It means that you have a unit like you got meters, you got time, which would be, seconds. You have things like grams. You have your units, and then basically you put something in front of it to let you know how much of that unit you have. Like, for example, and of course we'll go through the details, like you can have a meter, or you could have a kilometer, which is 1,000 meters. So meter in that case would be the unit, and whatever you put in front of it tells you how much of that unit you have. And the clever thing about this is that, oops, let's see, there's a comment. Let's see. Okay, so someone just noted that some people are kind of stuck waiting for the security to let them in. I'm just going to write their names down just so I make sure that they're on the attendance.
Yeah,
Thank you for, go ahead.
Isn't metric system very easy because it's all like decimal numbers? It's very exact. It's like, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, all the way to 1. And then it's like 1 centimeter and then it goes.
It's not exactly the numbers that you listed, but it is a pretty simple system. But sometimes I think that works against it in the sense that I think some people have a hard time grasping it because it is so simple and it is so clever of a system. That's kind of just my opinion, because like with other systems, there might be a lot of charts, but you just pretty much have to straight up look it up on the chart. With this one, the chart is like so simple and so short that a lot of people don't really understand what they're reading exactly. Yeah, but maybe that's just, again, my opinion. Maybe everyone will be good with it. Okay, so these prefixes are based on multiples of 10. So that's the clever thing about the metric system, is that they based it on 10. Of course, they did that because our number system is based on 10. So in this case, all you have to deal with is multiples of 10. You don't have to deal with American stuff where it's like, oh, there's 5,662 feet in a mile and nonsense like that. In this case, you're just dealing with like 1, 10, 100, 1,000, and that's it. So it's very nice in that regard. Okay, so this is a list of the quantities or the units, and then it shows their symbols as well. So you have length, and the standard unit is a meter, and the symbol is small m. Mass is grams, that's small g. Time is seconds. Electrical current is amps. Temperature is Kelvin. We're going to leave that out for now because we have kind of our own separate lesson on temperature. Amount of a substance is in moles. And then luminous intensity is candela. So I guess that's a measurement of how bright something is. Oh, let me just check the chat again. Okay. Yeah, no worries. Someone informed me. So you are listed on the attendance. And yeah. And then volume is in liters, which is capital L. So those are all the quantities. There's a couple of standard ones that we deal with, mostly length, mass, volume. We don't really bother with temperature because, again, we'll do that later. And yeah, so make sure you're familiar with this. Make sure you know the symbols and so forth. So here are the prefixes. So this is the only chart that you need for the metric system, unless you want to go, and there are bigger charts for the metric system, but that's only for more like obscure stuff that no one really uses. So this is a standard metric system chart. So these are all the prefixes. Let's go through each of them. So if there's no prefix in front of something, then, oh, actually, before I do this, let's do a recap on exponents. Yes, let's go to a whiteboard. So of course, exponents denote repeated multiplication. And with 10, as we've seen before, it's very easy. 10 raised to whatever number is just 1 with that many zeros after it, right? So for example, 10, like 10 to the 1 is just 10. 10 to the 2 is 100. 10 to the 3 is 1,000, and so on and so forth. So yeah, when you have a positive exponent, which is all we've seen previously, it denotes repeated multiplication. But on the other hand, you could actually have a negative exponent, and that denotes repeated division. It flips the number upside down, essentially. So basically, if you have a negative exponent, then 10 to the minus 1 will be 1 over 10, which is 0.1. And then 10 to the minus 2 will be 1 over 100, or 0.01. And then 10 to the minus 3 will be 1 over 1,000, which is 0.001. So that's what negative exponents are. They just reciprocate the number. So for example, if you have 10 to the 6, that's 1,000,000. If you have 10 to the negative 6, that's 1,000,000th. So I just wanted to clarify that for everyone, that it denotes division. Some people think that the answer equals a negative number, but it doesn't. It just flips the number upside down, giving you a small decimal number, but it's still a positive number. Because a lot of people, for some reason, they'll be like, well, if 10 to the 3 is 1,000, then 10 to the minus 3 must be minus 1,000. And no, that's not how it works. It works this way right here. So yeah, what else can I say about that? I guess that's it for that. Okay, so let's go back to the chart, because a lot of the chart is expressed in terms of exponents in order for practical reasons, but also just to save space. Okay, and later when we do something called decimal dumping, which is a way of converting, we deal entirely just with exponents, and it ends up being very, very convenient. So let's go through these. If no prefix is used, that is just 1. Like for example, if it's a meter, then it's just 1 meter. In terms of exponents, that's just 10 to the 0, because any number to the 0 is equal to 1. So no prefix is kind of just a trivial case. And now let's go up. So deca is 10 to the 1, which means 10. So if you have a decameter, that's 10 meters. Hecto is 100, so that would be 100 meters. Kilo is 1,000 meters. And then we got mega and giga, which are 1,000,000 and 1,000,000,000. And then as you go in the opposite direction, you go into smaller and smaller prefixes. So your length would get increasingly small. So deci is 0.1 of a meter. I'm just going to talk in terms of meters, despite the fact that, of course, it applies to all the different units. Centi, a centimeter, is 100th of a meter. Millimeter is 1,000th of a meter. And then micro and nano are a 1,000,000th and a 1,000,000,000th. A lot of these you will have heard of, and a lot of them are pretty easy to remember. So for example, like centi is 100th, and that's pretty easy to remember because like there's 100 cents in a dollar, there's 100 years in a century, etc. Micro and nano are easy to remember because like they sound small, and they are small. They're a 1,000,000th and a 1,000,000th. Everyone also knows giga, because like everyone pretty much knows that a gigabyte is a billion bytes, referring to computers. So that's another one that people tend to know. And hopefully everyone knows kilometers, at least anyone who drives, because otherwise driving would be very confusing if you had no perception of how long a kilometer was. But yeah, a kilometer is 1,000 meters. So these are all of our prefixes. Yeah, I recommend that. I mean, I guess in this case you don't. This is a tough one, because if the course outline always specifies that you're to do these calculations without the help of a metric chart. So in that case, we might have to do this test in person. I'll check out the outline and I'll see what it dictates. They might have changed it. Yeah, we'll see. What else was I going to say? Oh, and of course, be familiar with the symbols as well. So capital G is giga, capital M is mega, C is centi, M is milli. And then for micro, you have 2 different options. You have MC, or you have this little U thing, which is known as mu, which is a Greek symbol. I use mu because I like saying the word mu because it's a funny word. So that's basically why I use mu. On a more practical level, it's a better symbol because when you use MC, it's a bit confusing because you already have M for milli, and people can confuse it. They might just look at the M and they might mistakenly think that the C is a quantity rather than a prefix. So mu is a bit more clear, so I'll be using that on the tests and the assignments. So know the symbols and know the prefixes. And another thing that's important is knowing the exponents. Yeah, because again, later we're going to work entirely with exponents. You could kind of take some shortcuts when you do converting, which we'll look at later on. So yeah, you should know that when I say that giga is associated with 9, what I'm referring to is the fact that it's 10 to the 9. So it's a billion. It is 9 zeros. So each prefix is associated with a specific number like that. So yeah. So hopefully everyone knows what I'm referring to when I say things like that. Like when I say mega is associated with 6, it doesn't mean that a megameter is 6 meters. It means that it's 10 to the 6 meters. So yeah. So those are all the prefixes. And this is something I included just to show a bit more. These are not very commonly used. They're just more prefixes, but a lot of them sound funny, so I included it. So let's see what we have. So mega and giga, we got that. Tera is a trillion. Peta is a quadrillion. Exa is a quartillion, and then quintillion, and you got zeta, iota, femto, atto, zepto, yocto. all these weird names that presumably come from somewhere logical. But yeah, this chart right here is what we'll be using. Okay, let's see. This is a further reduced chart of all the most common prefixes, which are nano, micro, milli, centi, kilo, mega, giga. You could pretty much get away with just knowing this chart. I'm actually going to, I don't like this chart. I don't like that it's expressed in terms of fractions. Previously, we just had it expressed in terms of decimals. So that's my fault. I'm sorry for the inconsistency. After class, I'm going to replace this chart with one that's has decimal numbers, because in the past people got confused when it had fractions. So kind of just for now, just kind of ignore this part. Okay, so yeah, like I said, these are the minimal number of prefixes that you hypothetically need to know. So in terms of memorization, this is really not too bad. Really all it is just 1, 2, 3, 4, 5, 6, 7 words, and each of them have a number associated with them. So like the amount of memorization is pretty minimal and pretty impressive for a measurement system. But again, that's because they were smart and they used 10 as the base number. Okay, so now we're going to learn how to convert from one unit to another. So for example, converting from kilometers to meters, centimeters to millimeters, etc. Now, of course, you can only convert between quantities that are the same. Like you can't convert length to time or anything like that. So it'll be meters to kilometers, et cetera, grams to milligrams, and so forth. So there are two different methods of converting. It's called dimensional analysis or unit analysis, and that's basically where you use fractions to convert. And then there is decimal dumping, which is usually the method that everyone prefers. So we'll look at both of them. And decimal dumping is where you basically, to convert from one unit to another, you basically just move the decimal place over. That's another thing that's brilliant about the metric system, is that all it really involves is just, again, multiples of 10. So it just involves moving decimal places over, essentially. Yeah, so basically one is fractions and one is decimals. And in general—
Would you not just, if you know it's a rule of 10, couldn't you just multiply or divide by 10?
Yes, absolutely you could. Well, yeah, multiply or divide by the appropriate multiple of 10, yes. But some people get confused by that. So we will be going through like a little more of a detailed, methodical way of doing it. But yes, you're correct. Okay, so like, yeah, for example, what he's referring to is like, if you're converting kilometers to meters, then you just multiply by 1,000. That's really in the end all you have to do. But sometimes people don't know if they multiply by 1,000 or divide by 1,000, because it depends on what direction you're converting in. So we'll look at a fairly algorithmic way of doing this. Let me just switch to a whiteboard for a second so we can do some examples. Just hold on. Okay. New share, whiteboard. Let's get rid of this. So we're going to start with dimensional or unit analysis, also known as using fractions. So the question is, convert 0.375 liters to milliliters. And again, in this case, a lot of people could kind of just do this by observation. Like there's, if you look at the chart, there's 1,000 milliliters in a liter. So the answer is just going to be 375 milliliters. Some people can look at it and do it that way, but again, we have to, have a process so we make sure we arrive at the right answer. So the first thing you do is you look at the chart and you look at how liters and milliliters are connected. You don't have to worry about the 0.375 at this point. For now, you just do this initial step based on the chart. So we know that in 1 liter, there is 1,000 milliliters, because 1 milliliter is 1,000. 1,000th of a liter. So therefore there's 1,000 of them in 1 liter. So you write a statement that connects the two of them. And the next thing you do is you set up a fraction using these two pieces of info. Now, hypothetically, there would be two ways of setting up these fractions, right? There is, you could do 1 liter over 1,000 milliliters, or you could do 1,000 milliliters over 1 liter. So which one do we pick? The one we pick is this one right here. So the rule of thumb is that whatever you're converting to, that's the unit that goes on top of your fraction. So in this case, we're converting to milliliters, so we put milliliters on top. This is something I'm going to repeat a lot because people never ever remember it. I'm not sure why. So yeah, this is the only way that you can do it. If you did it this way, you would be converting in the wrong direction. So yeah, let me just write this. So on top is what you're converting to. And then on the bottom is what you're converting away from. So make sure you set it up in that format. Because I remember there was a class where I repeated this like 10 times, and then like people were stuck on a question for an hour, and then at the end of the class they were like, oh, I get it now. You have to put on top what you're converting to. And I was like, guys, I told you that an hour ago. We would have saved so much time. So just remember this right here. Okay, so this is the fraction that we use. And then the last step is you just take 0.375 liters and multiply it by that fraction. So you do 0.375 liters times 1,000 milliliters over 1 liter. Now you might notice that at this point, liters cancel out, which is good because then we're just left with milliliters, which is exactly what we want. So that lets you know that you're on the right track. So goodbye liters, goodbye liters. And then at this point, you just do whatever the numbers tell you to do. Like if there's a number on the bottom, then you divide by that number. If there's a number on top, then you multiply by that number. Sometimes it's, yeah, sometimes it's one or sometimes it's multiplication, sometimes it's division. But the important thing is that you set it up using this rule. That's the format you use. So what are these numbers telling us? 0.375 times 1,000, which is 375 milliliters. And that's basically what you do. Or you could have, in this case, hypothetically, you could have taken the decimal and moved it over tenths, hundreds, thousands, just moved it over 3 times, and that would be the same thing as well. And that's essentially decimal dumping. It's pretty much the same thing as using fractions. It's just a little less work. So yeah, so this is dimensional analysis. It's a little more inconvenient than the next one that we're going to learn. But the reason we learn it is because there are other systems where this method is the only one that will work. Because when you have other systems that are not based on multiples of 10, then you can't just move the decimal over because it doesn't work that way. So this is a more universal method that works even with the imperial system, which we'll look at later on. Oh, I'm sorry, my phone is ringing. Sorry. Hang up. Okay. Okay. Let's do another example. Oh, and in the slides, I'll move to the slides for a second. It just further clarifies the format for this. On top of the fraction is unit we are converting to. On the bottom is unit we are converting away from. Okay, let's go back to a whiteboard. Let's see, next one. So it says convert 70,000 meters to kilometers. 70,000 meters to kilometers. Okay, So let's do this one. So again, first thing you do is you just connect meters and kilometers according to the chart. So kilo means 1,000. So 1 kilometer is 1,000 meters. So I would write 1,000 meters is equal to 1 kilometer. Okay, so this is your initial statement. Again, you don't have to worry about the 70,000 yet. Some people try to insert it at this step and it gets confusing. So again, this part right here is just based on the chart. Now set up your fraction. So converting to kilometers, so put that on top. 1 kilometer over 1,000 meters. Okay, and last step is take 70,000 meters and multiply it by this fraction. Again, you'll notice that the unit that you're converting away from, it cancels out. So meters here cancels out, and meters here cancels out. And then in this case, you happen to have, on top, you have 70,000 times 1, which is just 70,000. And then on the bottom, you have 1,000. So you do 70,000 divided by 1,000, and you get 70 as your answer, 70 kilometers to be exact. So yeah, like I mentioned, sometimes you'll have a number on the bottom, which is in this case. In the previous one, we had one on top. But what's important is, again, that you just follow that rule that you put on top whatever you're converting to. Because some people think that, oh, I always put the large number on top or something like that. No, 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 no. That's not the case. You don't do it based on which number is large or small. You just do it based on where are you converting to and where are you converting away from. And then at the end, the numbers tell you what to do. So, and then in this case, I would just say, therefore, 70,000 meters is equal to 70 kilometers. So yeah, that is dimensional or unit analysis. Not much else I can say about it. All the examples are kind of similar. I'm just looking at the slides, and it kind of just gives you the chart again, the more minimal chart that you could use. So have that one memorized at the very least. Let's see if there's anything else that's interesting. So there's a ton of other examples, but let's do something different. And I don't know if we'll have time to do the next method, so I guess we'll do that tomorrow. Okay, so let's get rid of this. Now it says convert 3,500 centimeters to kilometers. So this one is different because previously you had one of the units with no prefix in front of it. This one's more unfortunate because it's centimeters to kilometers. You actually have a prefix in front of both of them. So what you do is you basically think of this as two separate questions. What you do is you convert from centimeters to meters, and then you convert from meters to kilometers. So yeah, in this regard, it's kind of unfortunate. When we get to decimal dumping later on, doing this type of question is way easier, but just bear with me. So let's just look at this. So part one would be going from centimeters to meters, hypothetically. Second part would be going from meters to kilometers. So let's set each of these up as a fraction. So first one, there is 100 centimeters in 1 meter. So that would be, and in that case, you're converting to meters, hypothetically. So meters will be on top. So 1 meter over 100 centimeters. I recommend writing this part out first before you write it as a fraction, because a lot of people set these fractions up incorrectly. Next one, there's 1,000 meters in a kilometer. 1 kilometer. Good. So setting that up, converting to kilometers. So you'll get 1 kilometer over 1,000 meters. So those are your two fractions in this case. And then what you could do is you could take these two fractions and multiply them together, and that will give you a fraction that directly takes you from centimeters to kilometers. So let's do some fraction multiplication. And we do it the same way that we did in chapter 1. 1 meter over, over 100 centimeters times 1 kilometer over 1,000 meters. So in this case, again, notice that some stuff cancels out, meters and meters cancels out, which is actually really nice because then you're just left with kilometers, which is on top, which indeed is what you're converting to. And then centimeters is on the bottom. So the cancellation here usually gives you a hint if you're right or not. And then the next thing you do is standard fraction multiplication. Remember, you just multiply the top numbers and multiply the bottom numbers. In this case, on the top, you just get 1 times 1. So that is just going to be 1 kilometer. On the bottom, you get 100 centimeters times 1,000. So that's going to be 100,000. 100,000 centimeters. So now this is your official fraction that you use to convert. And then of course, the last step is take 3,500 centimeters and multiply it by this fraction. Let's just do this at the top. 1 kilometer over 100,000 centimeters times 3,500 centimeters. So centimeters cancel out, which is good. Goodbye centimeters, goodbye centimeters. And then you just look at what you have. So on top, it's 1 times 3,500. So on top, it's just 3,500. And then on the bottom is 100,000. So you now divide by 100,000. So 3,500 divided by 100,000 is something 0.035 kilometers. 0.035 kilometers, which makes sense as an answer because like if you picture 3,500 centimeters, it's not very much. Like it's 35 meters. So it's like maybe the length of a really long room or the length of a gymnasium or something. So if you compare that to a kilometer is pretty big. So yeah, it's only going to be a fraction of a kilometer. So the answer makes sense in that regard. Okay, yeah, I don't think I have time to fully do the decimal dumping. Let me just think for a second. Yeah, I think we'll do that tomorrow. Yeah, so again, everyone, remember to hand in the assignment by tomorrow. I'm also going to post the measurement assignment just so it's up early. And you could technically start working on some of it if you want. Although actually I'd wait until tomorrow so that we cover both methods. Oh, someone has a question about reading week. Oh, I totally forgot that reading week existed and I was gonna look it up. When is reading week?
Reading week is the 25th to the 29th.
Okay, so in 2 weeks. Okay. So what's the question?
In the week at a glance, it shows that we still have these math classes.
Oh, it says we still have math class during reading week?
Yeah, and that's my question. Like, do we actually, or
does it say that for every class of yours?
No,
Yeah,
just math.
it would. Yeah. Oh, because like the thing is, it showed even though this college was closed on the Monday, we still had apparently classes on that week at a glance. So I think it's just like a glitch. It's just trying to keep things consistent.
Yeah, I think he might be right. I think it is a full reading week. Because on my timesheet, it does mention the reading week. Hold on, let me just double check this. Because I don't know why we would have like some classes on reading week or like, because we do have a reading week. Let's see. Timesheet, and it should say, let's see. But for now, I'm going to tentatively say that we're off on reading week and that we won't be doing any lessons. So that's my answer until unless I find out otherwise, in which case I'll let everyone know. But let me just double check that it does indeed. Oh my God, sorry, just give me 1 second. Someone keeps calling me. Just give me 2 seconds. sorry about that. Like, yeah, never mind. Okay. Let's see, reading week should be listed. Reading week is, oh no, that doesn't apply. Darn it, wrong timesheet. Anyways, the answer is we'll be off on reading week. I won't be doing any lessons unless stated otherwise. I'm sorry that my answer took so long. Okay. Oh, and I'm just curious, where does it say that you do have these classes during reading week? Is it just on your where does it say that?
Self-service when you go under the student tab and week at a glance.
Oh, okay. Is that just on iLearn?
No, it's on self-service.
Oh, self-service. Yeah, I'm not sure why it says that. Yeah. So yeah, I would just ignore that, and yeah, so we will have a full reading week. Let's see. Let's just stop sharing. Does anyone have any further questions? Any questions about the material? Let me just double check the attendance, and then we'll call it a day. Okay, we got this person, this person. And this person. Almost done. Okay. Good. So again, please send in the assignment by tomorrow, at least before the beginning of class. I'll post the next assignment, no due date on that yet, as per usual. And I guess that's everything for now. So if no one has any other questions, have a good night, and I will see everyone tomorrow. Bye-bye.